Good evening, everyone present here. A very, a very warm welcome to day 4 of Agri SAARTHI KRANTI 30-day National Agricultural Training Program. On behalf of the Agri SAARTHI team, it gives me immense pleasure to welcome all the participants and resource person in today's session. Myself Simran and along with me Kanishka. We will be representing the Agri SAARTHI team today and guiding you throughout the session. To begin with, I extend a warm welcome to our esteemed speaker, Dr. Anurag Saxena, and our organizing director, Mr. Ajay Kasana, Chief Secretary of Agri SAARTHI Society. Today's topic is AI and ML for smart DSS agriculture and futuristic animal husbandry. It's not just relevant but also a transformative topic. For us, students and agri professionals, this is a golden opportunity to learn how science, data, and technology work together. Now, let me formally introduce Dr. Anurag Saxena. Dr. Anurag Saxena is a senior agricultural scientist with over 3 decades of experience in agronomy, dryland agriculture, and climate resilient farming. He is currently serving as principal scientist and in charge Forage Research and Management Center at ICAR National Dairy Research Institute, Karnal, Haryana. His professional career spans key ICAR institutes including ICAR Central Arid Zone Research Institute, Jodhpur, ICAR NDRI, and ICAR Indian Institute of Pulses Research, with significant leadership experience as principal scientist and head in charge Regional Research Station, Leh Ladakh. His work focuses on cold and hot arid agro ecosystems, water productivity, protected cultivation, climate change, adaptation, tribal farming system, and sustainable forage production. He has led and managed several national and international research projects funded by agencies such as DST, ICAR, ICRDA, NICRA, and UNEP-GEF, contributing sustainably to agricultural development, livelihood security, and ecosystem resilience in arid regions. And he has received numerous national and international awards, including the Fakhruddin Ali Ahmed Award by ICAR. Dr. Saxena is consistently working on artificial intelligence since it was not in existence. From the last 10 years, he is working on AI. Dr. Saxena is the best speaker and expert on the artificial intelligence and its working and use in agriculture and animal husbandry. We are truly privileged to have Dr. Saxena with us today. With great respect, I invite Sir to share his insights with us. Please, Sir.
Thank you, Simran. Thank you, Kanishka. Thank you, Ajay, for inviting me in the series of lectures. It is the second time I am delivering my lecture in the Agri SAARTHI platform. This time I have seen that 20 more than 2,500 persons have logged in. So let me share my presentation first, then we will talk later. My screen is visible
Yes, sir, it's visible. Please go.
and it is moving.
Yes, sir, it's working.
Okay. So, dear students and my colleagues in the online platform, those who are joined, today we will discuss about the artificial intelligence and machine learning for smart decision support system in agriculture and along with the futuristic agriculture and animal husbandry. So, myself, Anurag Saxena, working in ICR since long, and presently I am working at NDRI Karnal. So you should see whatever we are doing nowadays, that is based on mechanical machines, hardware oriented, and manual and on-site control of these machines. And these machines are simple ones. And we are working with the unpredictable quality and quantity of the produce. But later on in the future or tomorrow, you will face or you will work with the smart machines that will be information oriented, software oriented, automatic and remotely controlled machines, network smart machines, and you can very well predict the quality and quantity of the produce, because it is a major change in the scenario. Because most of the policy planners, they are seeking the information on a country basis or on a large scale. For planning about the PDS system or any other supply chain management, they require the huge data or the prediction of the produce, and for price fixation also. So first we will talk about the precision agriculture, and it is a smart, sustainable solution for all, because precision is now a data-driven management strategies. Here we use a spatial and temporal variability, and these variability guide us the site-specific decisions. And our aim is always to improve the resource use efficiency, productivity and quality, profitability and sustainability in the farming. Because most of you might be knowing that our soil or natural resources are degrading nowadays at a faster rate, just due to our greediness and the requirement of the country to feed the 140 crores of persons. And another aspect is in the satellite farming, or you can say like this, we can monitor our farming through satellites or site image management systems. Then I have differentiated precision agriculture in two parts: soft precision agriculture and the hard precision agriculture. Soft is farmers' experience, intuitions, visual uh, leaf color charts, SPAD meters, data handling is minimal, and small and marginal farmers, we are working with this system. And another is the hard precision, where we are using the advanced electronics, data's, geopositioning systems, geoinformation system, remote sensing, decision support system, variable rate technology, sensor-based, digital, automated, and large commercial farms. Because this technology is very much useful for the large farms. And this is the concept of precision agriculture. Earlier, we used to work with the 10 to 100 acres of land, where we get the 1/10 or 1/100 acre for precision management. Because the idea is to have a uniform land for putting any input to get the major benefit of the input applied. There are 4 R principles for the nutrient management, like this: right source, right rate, at the right time, and at a right place. Right place means where the nutrient is in the soil is less, we have to apply more. Where it is more, then we have to apply less, so that we can make a balance in the input management, and ultimately we can save the costly inputs in agriculture. And mainly by bifurcating our fields into parts, just for the managing the variability, and heterogeneity philosophy we will use in the homogeneity. And we will have more efficient utilization of inputs for improving the resource use efficiency. It is simple one cycle I have listed here. We have soil map, or we have to create the soil map for the field. And from soil map we have to coordinate the crop, which crop we have to take, how much longest growing period we are having at the site, and which crop will fit well. And out of that crop, which variety is well suited to that conditions. Then again, soil conditions map we are preparing, yield maps, and all these data is integrated with the model and put in the computer, crop soil models, and treatment maps. And once the treatment map is prepared, then we go for sowing, fertilizing, and protecting the crops. In fertilization, we use VRT or VRA variable rate applicators, and the technology is called variable rate technology. And just for the same thing for protection of the crop from insects or diseases. Where the disease incidence is more or insect incidence is more, we have to apply more insecticide or pesticide. Otherwise, we are working with a very less uh, quantity of pesticides. And this whole system is controlled through GPS-based machines, and sometimes it is driverless, tractor or machine that can be operated remotely from a click of mouse. The machine can be moved here and there. And again, step 3 yield maps like this. I have put some figures, step 1, 4, 3, 6, like this. Then the status. What are the status of precision agriculture in India? Simply, if we 12 point or 13 million hectares is under precision micro irrigation techniques, it is widely spread. Then comes the 3 million farmers, they are using it. And most of the farmers are medium to large, and they are a progressive one. Because we cannot work with the less progressive farmers because they are very reluctant to take the new technology. Based on their resources or willpower, depends on their perspective. And we should grow for the high value commercial and horticultural crops also. Then these are some tools of precision agriculture like GPS geopositioning system, geographical information system, remote sensing, variable rate technology, and yield monitoring. Simply, all the machines are working on a sensor base, and they are controlled remotely. And another tools are leaf color charts. We can match the color of the leaf, and we can decide how much fertilizer is to be given to a crop. Similar way in SPAD chlorophyll meter, with the help of SPAD meter, we can judge how much fertilization is given or a crop is doing perfectly well. Then green seeker, another instruments. Then Pusa STFR, nutrient experts, systems are available that is web-based or app-based, and UAV drones. Then laser land labeler. Simply by labeling our land, we can increase 2% area just because land is limited. But why I am saying 2% rise in land? Just because we can apply irrigation water uniformly to the field. That's why yields are more, less water requiring, and we can save the precious water, which are very limited in our country. And for future generations, we have to save water for them also. Then micro irrigation systems, soil moisture sensors. These sensors are used for automation of irrigation. Then comes the micro irrigation, micro drip irrigation. It is better technique for widely spaced crop. But nowadays, these drip irrigation systems are also used in the paddy crops, the upland paddy, where we are losing 10% of yields, but we are saving 50% of water. So the choice is farmer or ours that in which direction we have to move. Either we have to save water or increase the yields. Then the crop sensors are also available, which are sensing the crop conditions and guiding the doses. Then these are some global trends. Our country population is 140 crores, and in world it is 9.6 billion by 2050. And we will require 70% of more food with the same natural resources. Because natural resources are not going to increase, we have to conserve it and use it judiciously. Then comes the shortage of water for irrigation. Most of the time, we see that there is drought and less rainfall. The crops are not able to perform better sometimes, and climate change is also occurring here. And these climate change, rain is somewhat same, but the rainy days they are going to decline with the climate change pattern. Temperature is rising. Most of the rabi crops they got suffered with the rising temperatures. Then reduction in arable lands due to erosion, soil erosion, urbanization, industrialization, and excessive use of the livestock. The solution is AI. Then what is intelligence? Artificial intelligence and intelligence. Just like us, we always say the humans are the intelligent race among on the earth, and we are having ability to acquire and apply knowledge and skills. This is intelligence, simple definition. And human intelligence is the intellectual capacity of a humans. And when we transfer our intelligence into machines through binary digits, 1, 0, that is called artificial intelligence. And this intelligence is exhibited by machines rather than humans and animals. And there are several agents which perceives through software and what we want the machines to do work. So we can have a good environment friendly situation in future. And sometimes we always say that sometime later machine will overcast humans. But it is not there because we are the creator of the machines and we are giving softwares. But we can't say anything because some notorious person may change the software and the machines will malfunction. And these are the steps of uh, artificial intelligence. The deep learning is subset of machine learning, and machine learning is subset of artificial intelligence. And the technique which is working like or we are mimicry of the human behavior. Whatever we want to see, what we are doing, and the machines are doing the same thing at a higher efficiency and quickly. And as I told you, the machine learning is a subset of AI, and it uses statistical methods and make it machine to improve with work experience. Just like us, we are daily, on day-to-day basis, we are learning every day small thing or better, small thing than better management practices. Likewise, machines also, because earlier the softwares which were not good, then machine was working not very good. But nowadays the machines are working very efficiently. And these are the steps or the agents involved in artificial intelligence. The intelligence like ability to interact with real world. Simple example is speech recognition. Whatever we are talking, the computer is typing. It is simple method of AI. Understanding and synthesis, image understanding, ability to take actions like ChatGPT and different AI platforms, they are available nowadays, which might be you are using as efficiently as I am not so confident about these AI platforms, but you might be champions of these platforms. Then knowledge presentation, reasoning and planning. We can model the external world by the giving inputs. Simple input is more important as compared to the output because whatever input we are providing to the machine, it will give some output. Whether it is useful or not, it is we have to decide that the output is useful or not for the work efficiency. and we can solve new problems, plan, we can make decisions also given by the machines, that these decisions are the unbiased. Because sometimes we are biased in our working environment or our working situations, but machines, they whatever we have fed, they are giving the unbiased decisions. And they are also able to handle the unexpected problems and uncertainties. Then learning and adaptation means continuously learning and adapting. And daily you are seeing that your phone or computer, they are getting updates. So simply we are updating our machines through softwares and whatever we are learning every day, and in a week or a month, we are updating the machines. So it is simply just like the baby learning to categorize and recognize animals. Very small babies, they are in the nursery or KG, they are seeing the pictures and identifying the animals like that. When the artificial intelligence can address these are the challenges, self-learning capabilities to take decisions, enhance quality produced, like go-to-market strategy, AI-powered solutions we can provide, machine intelligence. This is acting as a bridge to enhance the quality produced with less efforts and providing timely and doorstep solutions to a remotely located farmer. Because just it is an example, simply I quote a remotely placed farmer. If he wishes to visit a research station, it can take 1 or 2 days to come and going back. And the mental and physical fatigue. But at the doorstep solution with the app, with the help of app, we can provide the doorstep solutions there. Simply, he can click the image of the problem and send it to the research station. And with the help of app, we can provide the solutions at his doorstep. Then these are some basic things, but it may not be much more required for you also, because three types of narrow intelligence, general intelligence, and the super intelligence. Narrow intelligence means weak AI. Simply the machines which are programmed for working for a one or at the most two performers. Just like Alexa, robotic milking machines. These are the having narrow intelligence. General intelligence is a strong AI. The machines which possess the ability to perform the intelligent tasks like self-driving cars. And super intelligence is like this, referring to a time when the capability of computer will surpass humans. It may happen in future, but still we are surpassing machines. Just like some time back, the best example is the chess game. It is won by the Gary Kasparov a long time back, and he defeated the machine robot. But nowadays the robots are much more intelligent in planning the next move in the chessboard. See, these are some agents. The actuators functions agents which are perceiving, like camera, like our eyes is camera, then sensory organs like ear, nose, they are perceiving the things through binary one, and with the help of softwares. And these are perceiving environment. Agent functions maps, agent programs and runs the architecture, and agent equal to architecture plus program. And what are the agent types are different: medical diagnostics, satellite image analysis systems, part picking robots, interactive tutors, cooking agents, taxi drivers, and like human agents, the eyes, ears, organs of sensing, hands, legs, mouth, other body parts, or actuator. Similar way, robots, they are having cameras, infrared range finders for sensors, various motors for actuators. Because movement of legs, that is through motors or power. These are some elements: machine learning, neural networks, evolutionary computation, natural and language processing, expert systems, computer visions, robotics, speech interpretation. These are some elements. After these elements integrate, then the best AI we can experience. Then analysis, when machine learning analyzes, the study of computer algorithms improves automatically through experience, use of data, and sensor-based technology at animal farms. And nowadays you are seeing AI applications everywhere. The email spams, malware filterings, support system, online support systems, search engines, product identification. And the best way, when you are searching one ad, one product in Google or Facebook or Instagram, next time when you go in the same platform, they will show the search you have done, and in a better way. Different type of situations or products they are showing. That is done through AI. I think this will not be very useful for you, this, because this type of works, this is for computer engineers. And being a agriculture scientist or agriculture graduates, you require your expertise in getting your work done through the help of IT person, computer scientist, or computer operator. So in all that my lectures, I always say, like, it is a coordination between the team of a two, agriculture expert and the computer expert. Because how much effective way you are using in telling your problem to the computer programmer, and how best the computer programmer is making a program to solve your problem at the ease. But even though this is basic structure of machine learning, when we give input, there are some outputs. The simple neural networks, feature extractions, classification, clustering, these all the things have been done by the machine, inside the machine, and you are giving input and getting the output. And this is the part, it is for computer scientists or computer programmer. Similarly, with deep learning, the, the big neural network, they are more complex machines, and different type of platforms are available. Expert system. It is just like computer program. Once you click the web link, you get a expert system. You put some input like how much fertilizer you have applied, like that, and yield prediction is given. Or if you have put one diseased leaf, it can predict which disease is occurring and what is the control of that disease. Then another is the computer vision. These information, always the computer is using the images. The more number of images we fed for machine learning, the better results we are achieving. Sometimes it is up to 99% accuracy. If we are using less number of images, maybe 50% or 60% accuracy is there. Then the machine does the segmentation and algorithms like K-means, image classifications, to support vector machines like SYMs. And one is speech recognition. Whatever you are telling to computer is able to recognize your voice or not. So in that way, in that case, you have to train the machine about your speaking style. Then fuzzy logic systems, how much truth, degrees of truth is there, and it is based on like that, it is not true or false. Then robotics, where the artificial intelligence plus mechanical, electrical engineering plus computer science. The combination of these gives you a robot, a working robot, which are doing excellent works nowadays for computers and controls, then ANI, neural networks that I have already told you. Then agriculture information management. You are growing crop, sensor is sensing the condition of crop and the soil conditions, and it is giving to a platform. Then the data is transported to the through software, data is generated. Then AI application is there. That AI gives you decision. And from that decision, the actuators are doing the work. It is simple diagram for a AI to work. Then these are applications of AI and machine learning in agriculture. Basically, it is crop yield prediction and price forecasting. The higher the yield, less the price. Less the yield, higher the price. It is a demand and supply game in the market. Then agriculture robots, they are available now. Intelligent spraying through drones, or you can say UAV, crop and soil health monitoring through different apps via sensors and diagnosis of disease. Then simple flow chart. How can we go for this output? Simple, we are having the past yield data, weather data, soil data, and management data. Through this, we train the machine. And once the model is formed, then that model predicts the yield. The how much accurately we have taken the past data and trained our model, and that much accuracy it will give you. And we can go through crop modeling also, or machine learning also. Yield prediction, flower prediction, biomass prediction, water source prediction, like that. Then agri robots. They are very different operations the robots are doing nowadays. Seeding means or sowing, planting, weeding, harvesting, and post-harvest operation. They are always all done by the robots. Seeding robots like this, and the harvesting robots are harvesting the tomatoes here, and wheat killing robots. It is working through laser machines or just picking the weeds through sensors, manipulators, control systems, and power supplies and effectors. Because if it is one component is not working, then the whole machine will go in vain. So it is a coordination of all components. It is just like our body. If one part is paining, the body feels, and most of the work is difficult to perform. Then comes the intelligent spraying. Through image acquisition, different thousands of images we have taken for machine learning. The best part is at a different angle, different uh, quality of the images from high resolution to low resolution, because we don't know which camera a actual user is using. It may be low resolution or high resolution camera. If it is high resolution camera we are using, then it is good output we are getting. And we can train the drones through AI where we have to spray more, where it has to spray less through GIS mapping. Because map is fed on the controller palm and drone is automatically sprays there. Then diagnosis of disease is just like same thing. Images, the computer, different lesions, it demarcates which is the affected part, which is not affected, which is healthy, which is not. And after assessing the losses, it gives you solution about the doses of the pesticide and which pesticide has to be applied. And sometimes some experts, they are also sitting and seeing the images, they can also give the advice about these controls. Simple thing. Once you have taken an image, and that is a raw image, we have to clean it just like if say 10 square centimeter area we have taken as an image, and the affected part is hardly 2 centimeters square. Then we have to clean it and mark this affected part. And then we go for feature extraction. Because this feature extraction, it is a part of scientists. See what is happening in the plants, and that solution and that disease part, that is given by the scientists, and the computers programmer, they put in the software, and later on the actual user is getting the information. And after the last is a trained model. Once that model is trained, we can get a good output. Here we can have some crop readiness identification. The crop is ready to harvest or not, because sometimes we are very lazy or biased. Should we go for today harvesting or tomorrow? But the machine sees or senses the weather conditions also, and the crop conditions, the fruit ripening stage, and immediately it can give you answer. It go for today or tomorrow. Similarly, disease detection, fuzzy logic models like ANN, ANF, support vector machines for forecasting disease incidence. Once disease incidence is forecasted, then we can go for controlling it based on the leaf wetness. Then FUSL, it is a platform which is implemented in Chhattisgarh and Andhra Pradesh, which is saving 50% of water. Downy and powdery mildew disease predictions for predatory sprays in the vineyards. Optimizing the agronomic inputs, because being a farmer, we have always a motto of saving in costly inputs and getting higher yields. Through this precision, we can save some inputs and getting the higher benefit cost ratio. Disease pesticide uses, once we are saving the money on the pesticide use or pesticides itself, in that way we are not only saving our money but also our environment, because higher use of pesticides is creating problem for the environment and plus human health, animal health, like this. And computer vision and deep learning. Through drone sensor and GPS chips, we can have different inputs, and we can improve the resource use efficiency in terms of irrigation water, fertilizer, pesticides. And if we are able to detect the infestation early, then we can control the disease insect at a early stage, very less damage to the crop done by these entities. Then comes the ICTs. ICTs, cities, we can have a daily updated prices of commodities. Whatever price prevailing in the market, a farmer can get the information and he can take decision whether he should go for market for selling or not. Then farmers get fixed price for the production and consumers, and they can sell their produce at ease. Market opportunities they can explore. Then use of different online platforms to advise farmers technical matters, or just like I am enlightening you about the AI on a Zoom platform. Modern measurements, automation technologies, where we are experimenting for the new crops and their adaptation for temperature, humidity, and wind and light. Because it is important when you see the change in the weather pattern, the rainfall is shifting. Earlier days, it used to come in the June, but now the monsoon sets in the northern part of country. It is in July end or August. So extra water is required for irrigation, or we can plan accordingly, go for less water requiring crops, grow in August, September, and harvest in October end. That way we can have a good management of our natural resources. Then these, you also know that temperature, humidity, rainfall, moisture, and energy is important for crops. AWS, automatic weather station, networking enables us to observe the variation in different parameters online. And they are equipped with Wi-Fi system or GSM system. You can get the all information on your mobile phones or on your desktop or laptop. Early warning systems enables us to prior decisions to minimize the risks. And the last is the real-time monitoring to reduce the risk due to flooding or drought like that. Then supportive technologies which are used in promoting these applications like UAVs, unmanned aerial vehicles like drones, remote images that is taken from the satellite or the drone camera or spectral band imaging systems. These images, spectral band images, are used nowadays to predict the soil moisture conditions, soil conditions, crop conditions remotely, just by judging or assessing the condition of crop based on the color. And IoT-based sensors, biosensors, nano-biosensors, application of big data. See, this is one example how the AI automation in irrigation is being done. See here, the sensors are placed in the crop, on the soil, within the crop. These sensors gather data and send to receiver. And this receiver send instructions to the timer and relay. The pump operates or not, it depends on the timer and relay. Once the desired moisture is not there in the soil, it automatically updates the on signal for the pump, and the pump is on and water irrigation is being done. Once irrigation is over, it automatically closes it. See, this is one diagram where we can have simple. The sensors are here. Soil moisture sensor, it gives to the control unit. A mobile user can get, and this is sending instruction to the motor, and water is coming from here to area for irrigation. Then comes application of IoTs. This is a technology or technique utilized for fertilizer doses, soil condition, pests, plant stress identified, soil testing through sensors, remote sensing, airborne sensors or satellite images, huge data on weather, soil, pest infestation, drone images, researchers generating, they are generating huge data, but the all data is very difficult to handle. So we use samples of these data and training the machines. In sensing data, providing strong insights, and where we can use it, IoT, it is soil moisture monitoring, temperature monitoring, automation of irrigation, drone-based surveys, crop readiness detection for harvesting techniques. Drone-based surveys means when we are having a large farms and we have to harvest fodder for animals. Either the one way is we have to move physically and see the whole field, the crop which is ready to harvest, we can go and harvest it. And the another way, simply fly a drone and we can have a picture of a whole field and we can decide this area of the farm is to be harvested today or tomorrow for animals. This we are using the IoT through edge nodes, device nodes, sensors placed in the farm orchards, collects data and sends over the connectivity technology. Then gateways, physical hardwares, and software of your phone. And these are allowing the data to transfer from sensory device to the platform. And app, another is apps, mobile apps, and user to view data and take the fact-based decisions. And these are some portals, apps and portals, soil report, sensor node put in the soils. There, through these technology, any user can get the information about their farm. Then precision agriculture, then where it is can be placed is the fleet management of the animals, arable farming, livestock monitoring, indoor farming, fish farming, forestry, and storage management. Through simple putting a chip in on the ear or neck, it can manage the fleet very well. There are some startups which are doing very good work, like Blue River Technologies, Harvest Crew robots for crop harvesting, peats, the machine for pest and soil defect diagnosis. These Blue River Technologies are working on the herbicide resistance and weed control. So this technology is 250 weed species. We have resistance to herbicides. The robots developed by this California-based company named See and Spray with this monitors, vision monitors, and this machine is spraying herbicide precisely on the weeds because this is programmed for the cotton plants. Similarly, crop harvesting robot, the Crew. This is developed by Harvest Crew Robotics to harvest strawberries. And one robot can harvest 8 acres of strawberries and it can replace 30 human labors. Then the plantics, you all know very well. Plantics, simply identifying a plant, simply putting one leaf or flower there. And nutrient deficiency in soil, particular foliage patterns, because all the things we have visualized through the plants and the soils. And these are startups in Indian scenarios like crop advisory, we are providing through Plantix, Crop and AgroStars, supply chain technology, and output market linkage through Ninja Card, Waycool, Dehat, Agri Biotech, the Green Pod Labs, finance and insurance like Jai Kisan, Unnati, farm advisory platforms like Krishify, Farm Bees, Input market linkages, Big Heart, Gramophone, allied sectors, Dudwala, Aqua Connects, integrated services like Innoterra and Nepanta. And these platforms, crop management platforms, work on using the ANN, robotics, Demeter, fuzzy cognitive maps, and the using ANN, it predicts the crop yields. Robotics, Demeter can harvest up to 40 hectares of crop. Fuzzy cognitive map, it gives the cotton yield prediction and improves crop pod season management. Another is the disease management, computer vision systems or genetic algorithms work at a high speed and do multitasking. Then different expert systems. Normally, expert systems are made for a single crop. And faster treatment for disease control, cost effective based on preventive approaches. Then weed management, different type of precision weed management, autonomous weed robots, robotic weed control, weed detection and removal. Different crops I have listed: pepper, sugar beet, cotton, sugarcane, and the algorithms for weed detection, weed removal methods, smart sprayer, high power lasers, smart chemical spraying, robotic arms for harvesting. Here it is the accuracy I have listed: 71%, 84%, 88%, and 93%. 93% accuracy is very good in identification. Then automation of irrigation. It is the easiest one. IoT sensor for data collection, increase efficiency, sensor for measurement of soil temperature, wind speed, evaporation. It predict and tackles the drought situations, fuzzy logic, IoT-based sensors, drip irrigation, then AN multi-layer neural models, sensor for evaporation decrease due to scheduled and saving observed in the water in the electrical energy. Machine learning algorithm like Zigbee, optimization of water sources. Then comes the big data processing. When the huge data is available, it is very difficult to handle on a single PC or a single laptop. For this purpose, majority of the companies are using cloud computing. They are sharing space for big analysis. And after putting on the cloud, analyze them and get the output in your PC or mobile phone like this. It is one example is the Google Cloud. Every company is having nowadays this clouding. Apple Cloud, Google Cloud like this. And this big data is used or have a wide variety, variability, arriving in a increasing volume with high velocity. Why it is important? It may helps in marketing, making a smart decisions about crop and land. And these are some areas where we can use this big data: yield prediction, fertilizer requirement, rainfall patterns, cattle behavior analysis, tracking animal movements. Then one flow chart, how we can go for this AI system. Simply, one method is remote sensing or GIS mapping through QGIS, RGIS, or Ardas Imagine, or Google search engine, Earth engines. And here, these are working on a large scale. But on a smaller scale, we can have a gridded data, climate data through IMD, or station data we can make. And this historical climate data we can analyze at a Google search engine, or modeling and prediction we can do through models. And through these models, we can have yield measurements, pest management, pest monitoring, nutrient balance, water balance, machine learning for big data-driven decision support systems. And ultimately, we can predict the yield forecasting, price forecasting, and anomaly in forecasting of weather and contingency planning we can give the farmer. This is another same thing in a different way. Remote sensing, we can use NDVI, crop area, leaf health status, land use cover, anything we can use through SPAT, green seekers, leaf area index, leaf temperature, croplands. And through this cropland, we can predict yields. Through GIS mapping, we can predict yields. And we can also measure the transpiration, leaf nitrogen content, water content, and this will enhance the yield attributes and ultimately leads to the yield prediction. Then comes the animal husbandry, where we need these things, the sensor nodes, small gadgets, electronic gadgets. They gather the information, various behaviors and health characteristics of cattle. Data acquisition system, they are acquiring data and wireless communication, communicating data through data loggers, through Wi-Fi or Bluetooth connectivity. Then the data goes to the AI algorithms. They analyzing, generate relevant insights, and give the behavior detection, disease diagnosis, and prediction. Then comes the user interface and visualization. This should be user friendly because once the app which is very user friendly, that is get more downloaded than the other ones, because it should be easy to understand for a user. Then algorithms for prediction of disease and conditions in animal husbandry. Mastitis, the bag of words or BO, gradient boosted tree, GBTs. They are working on somatic cell counts in the milk, electrical conductivity. They can, through these, it can predict the mastitis. Lameness is the fog computing classification and recognition tree, CART. This diagnosing through leg movement, neck movement, and or image or video data. Then postpartum disease, random forest algorithm, RFA. It is depending on the lactose yield, protein production, and the milk yields. Mastitis, when in nowadays where the large dairies are there, most of the pakka floor is there in the dairies. When animal sits on this surfaces, hard surfaces, and that is high temperature or cold temperature, their teats get ruptured. And in mastitis, blood is coming with the milk. That is called mastitis. And the whole lot of milk is discarded. That way, it is a huge loss for farmers when the mastitis is there, and then the farmer has to go for the treatment of their animal to the veterinary doctor. Then milking machines. It is a very common feature in dairies nowadays. Handless milking is there. The animals, they are as trained in such a way that they are coming in the milking area, and when they feel like this, and the machines, the four milking machine cups, they automatically fit in their teats or udders and start milking. And the sensor, when the sensor sense that there is no milk in the udder, they stop the milking and remove the machines. And these machines also cleaning and sensitizing their teats, color impurities, and they are identifying and separating the milk from the good quality milk. Then these are the feeders, robotic feeders. It gives the fodder or the cattle feed where it is very less, automatically sends and give the fodder in the mangers or roughages. It is another type of the best. The worst part of dairy is the cleaning of the dung. Then there are automatic robots are available which are cleaning the surface, but it should be some smooth one. In on rough surface, it is not working well. Then drones, it is already, I have told you, like crop growth monitoring, operations optimizing, monitoring crops through airs, spot diseases, can implement more efficient systems, and the benefits, effective and adaptive techniques, 10 times faster data and quick decision making, less wastage of resources, accuracy rate is 99%, useful for crop insurance claims, and ultimately the enhanced production. Then another thing is the managing a herd. Manual vigilance of livestock herd can keep track of cattle, where cattle is going. Also capture of pictures and pasture areas where the pasture is available. They always the farmer will lead the animals to that area. Then these companies, some Krithi Robotics, Dronitech, Saga Defense Engineering, DJ Enterprise, and Sunbirds, they are starting work in building the commercial drones in these India. Then smart precision farming. It is using the physiological behavior and production indicator of individual animals to improve the management strategies of dairy animal profitability and farm performance. Use of technologies that makes farmer less dependent on the human labor. Most of the work is done by the machine, and human labor, which is very costly and difficult to manage, and they are not available also at the time of milking or in the peak rush hours. And this monitors the health also, production, and translates the results into a useful information. So walking activity or lameness activity we can measure through these sensors which are put on the leg, and daily movements like your smartwatch, how many steps you have taken during the day. The similar way, how much feed intake it is done, standing time, lying time, and these changes can be done very frequently. And pedometers, lameness, early, before, and current. If it is animal is lame, it is indicative of it is sick. Then feeding behavior. We can also judge the feed intake of the animal. If it is consuming the feed at a voluntary intake level, then it is all right. Otherwise, if he is leaving the fodder or the feed, then the animal is sick. And we can immediately get the data of that animal, and we can treat the animals immediately. This is simply found the healthy animals spend more time at the manger, while the sick animal they're spending less time at the manger, and visited feeder immediately after the feed delivery. Healthy animals. And changes in short-term feeding behavior, dairy cows occurred on the onset of health disorders like this ketosis, acute locomotory problems, chronic lameness, like this. Motion activity instrumentation. We are putting the electronic collars, ear tags, speedometers. They are having sensors which sense and shows reliability related to status of animal. The animal status is estimated through the position, activity, temperature, live weight. These are some parameters to judge the animal health. Then another behavior sensors, detailed record of animal behavior. We are sensing head angle, head acceleration, leg acceleration, steps, swelling and jaw movements like this, biting and chewing, sound, weight, heart rate, core temperature, all these activities have been sensed by the sensors at a remote area. Then the human pH and the temperature. The pH is more important in the human for digestion. Then these sensors measures temperature, pressure, motility, and the pH in the human. The human pH is reliable and accurate diagnosis of terminal acidosis. If acidity is more, then less digestion. And this continuous monitoring of human pH is possible through wireless telemetry, which has capacity to subaccurate terminal acidosis. So we have to measure these things through the machines, because every time when you might have seen the veterinary doctor, he is putting hand inside the vagina to clean it and sense the pregnancy like this. Then body temperature measurement. The best part of the any ailment is a body temperature. If it is more than the normal, it is under fever, some ailment in the body is occurring of the animal. So we have to diagnose it for which disease the animal is getting feverish. And estrus direction, it is important for breeding purpose, for AI, artificial intelligence insemination. Normally in the village it is say that when a cow is running by keeping her tail upside, it is in heat. It is good saying, but we can predict the estrus just before 2 hours or 3 hours before, because when the animal is coming to the heat, that time is very crucial for the AI. And once the AI is done, then breeding a new one is very easy. Otherwise, once we lose that heat period, then again come in the next extra cycle. We have to manage it. Then farm management system, the track, monitor, manage through health, nutrition, behavior, milking frequency, milk production activities in real time. It can be put in the tail, neck, ears, leg, any part of body, and devices are Hardman, Smack Stack, Mukol, Smart Bows. Then this is everything was fine, but now the challenges. Because taking these things to a research farm, it is very easy, but for our farming community, it is very difficult to convince them, because they have limited literacy. High-tech machines are required, and most commonly the climate is changing rapidly, and our farmers has to be updated accordingly. And our soil is deteriorating because of inappropriate use of chemical fertilizers. This we can control through these AI systems, optimal use of water and other resources, generic fertilizer uses, farming exposed to uncertain weather conditions, and lot data required for machine learning. And mostly this thing has to be done in a collaboration, because some photograph I am having, some photograph you are having. That way, if we collaborate it, then we can have a double of images, double of information. Likewise, a common platform may be there that will help the others to develop a good AI module. And right now, the agronomical products AI is very much in operation in seed sowing, fertilizer, pesticides, rather than in field precision solutions. Sometimes it is the controversies like the pollinators, natural pollinators. When I was child, I was used to see several butterflies, several honeybees, several flies, which were the natural pollinators. But with the use of pesticides, they are vanished now. For that purpose, fly robots as a pointer come in the existence. It is a plastic one, very small, just like a mosquito and the fly. It sits remotely controlled, sits on the stigma of a flower and pollinated. This is not a old one. It is a very old one. It is the cartoon of 1950s, published in U.S. newspaper. The lady is going for a computer date and coming out with a robots. Then the controversies like just like the potential job takeover these AI or the machines. And just because some technical persons will get more jobs as compared to the untrained persons, or some skill is required to get acquainted with this and getting good jobs. And these, all the technologies, they are growing laziness in humans, growing cost in our day-to-day lives. Priorities, argument is always there. Then relation with robots. Relation with robots, it is our human tendency because robots do not have any emotional power, but humans are having. Some time back, one movie came, Android, I don't know the exact name. The one white color robots and one old man, they were good friends. But the man have emotions, but machine does not have. So it matters because in future AI is going everywhere. It is going everywhere, but in future the use of these AI systems will be much more. For that, we should know about it and understand it to cope up with the pace of changing the technologies. And it is just because we are interacting with it on day-to-day basis still now. And in the last, the AI is no match for our stupidity. Means we are more stupid than the machines. Thank you very much. This is all about I wanted to share with you. Now it is your turn to ask me.
Thank you
So
very
Ajay,
much, sir. Dr. Anurag Saxena for the inspiring and helpful connecting session. Staff, we are extremely grateful for your valuable time and for sharing your vast knowledge and experience with us. The session has given us a deeper understanding of the AI and MLs from DSS in agriculture and animal responsibility, as has been for futuristic. We will now be moving on our query and interaction session. Before we begin, I would like to briefly share a few instructions for the participants. Once you have questions or queries, I kindly requested to send your queries to our team members. On your behalf, we will ask the question to our esteemed speaker. We request you to keep your questions short, email, and relevant to today's topic. You can post your queries in chat section.
Sir, we have a question. In India, most people depend on agriculture, but Indian farmers are not familiar with the computer system. Then, how can we adopt AI technology?
That's why I was telling you, our farmers are illiterate ones. Just because every farmer is using phones, once that this technology is so much easy for understand by the illiterate persons, then only it will be applicable to all farmers or all persons useful. Just because when the mobile phones have come in the existence, nobody was knowing what is the utility of that phone. But nowadays everybody is using, and everybody is using more than the smartphones also. Once they are able to operate the mobile phone, then they can operate the app on the plays on the mobile phone. Because farmers has not required to do anything. They have to just click the photo or simply put a query on an app, and they will get the answer straight away.
Sir, we have another question from Shweta. She's asking that how we can use AI technology in farming for less land.
For landless,
Less land.
I'm not getting you.
Yes, sir. For the landless labor and the person who is having land in small quantity amount.
See,
Yes.
landless labor or landless farmer,
Okay,
they can use the
so
technology through cooperatives or the custom hiring centers. Because most of the machines, they are costly ones. They can be bought or can be placed in a custom hiring center. On a rent basis, they can hire it, take the advantage of that, and move further. Because purchasing each and every farmer, it is not possible. Neither it is available for them in the market in abundance. Costly, less availability, and less utility for the whole year. Just like tractors or implements, they are using for hardly 10 days or 20 days in a year, and rest they remain idle for the whole year. The best way is to take on a rent basis. That will be better. In that way, the agriculture graduates, which for which the government is funding, to go for startup, to start a custom hiring center or plant clinics like that, they can also get a job, or not a job, they can start their own business through this. Because agriculture graduates are more important for popularizing this technology.
Thank you, sir. So we have another question from Dipali Barari. She's asking, machine is okay, but can their sensor radiation is harm to the animals and also to the inner part of the plant? So what about that?
Still, there is no study has been done about the destruction made by the what you call radiations. Because it is very less radiation, or rather we can say it is a safe limit, under safe limit radiations, which a human body, animal body, or plant body can sustain. But still, the question is valid. It has to be studied, the effect of these radiations on the human and animal health. Still, I agree with you.
Okay, sir. Thank you. There is one more question from Harleen Bedi. How are satellite capabilities and infrastructure of ISRO can be used for agriculture survey and predicting the pest disease spread, yield estimation, etc.?
Yeah, it is being done. Simply ISRO satellites, It is coming on a spectral band through spectral band cameras. That images are put on the GIS system, and the color of that image and through ground truthing, they we have to train the machine. And once machine is trained, then any image from ISRO, anything, we can predict the condition of soil, crop condition, harvesting time plus disease condition, and even the control measures of that causal organism through this. And policy planners will get the reliable data for making a policies for the country. Because ISRO is already spending a lot of money on this agriculture side.
Thank you, sir. There is one more question from Manoj. He's from University of Agricultural Science, Bangalore. He is asking, is there any scheme to support to implement high-level technology sensor in farmers' field, and it should be able to applicable and used by students?
Uh, then you have to go for a collaboration with IITs or NITs because they are working on these machines. Because our job is not to develop a machine or working on that machines, because it is in a preliminary stage. Once the machine software is developed according to our requirement, then only the technology will be cheaper and easily usable. And moreover, these machines, they are costly ones. Even the research institutes, they are not able to buy it for student purpose. Simply, it is under experiments, and now slowly it is coming to the field. And in the next 10 years, I can visualize that lot of machines will be available in the fields for this purpose.
Okay, sir.
Yes, sir.
The next question is, please ask by Humaid Singh, MSc Chemistry student from BHU Varanasi. So the question is about Bharat Vistaar and its application recently launched by the Ministry of Agriculture and Farmers Welfare.
Which
Bharat Vistar.
Bharat Vistaar.
Bharat Vistar?
Yes, sir.
Bharat, I am not aware of this now. Still, I am listening first time. The Bharat Vistar, Ministry of Agriculture and Farmer Welfare. Can anyone enlighten me about this? Sorry, I am not aware.
It's okay, sir. Let's move to a new question asked by Vinu P. Gobra. He asked that what about marginal farmers? How can they implement AI in agriculture and sensors? Would be high, expensive for marginal farmers, and how could government support for that?
Everything is based on government subsidies. Something has to be done by farmers also. Because once a thing is given on a subsidy basis or on a free basis, that is not used by them only. It is all type of subsidies which government is giving. They are not using properly. Simply once the part of money that is invested by the farmer, then only they can know the worth of that equipment or the machine. Even though the government is providing funds on a loan basis, on a subsidy basis, or to popularize these things, the AI machines. And now you might be knowing that 3 lakh persons have been registered for AI conclave in Delhi internationally. It is going on nowadays. For a small farmer or the marginal farmer, this technology is not so much useful now because it is a costly affair. Because they are not able to hire it also. And they don't want to spend more money on this type of ventures, because human knowledge is much, much better than the machines. Simply, machines are making us lazy. We are not doing our work. They are, our work is done by the machines. Because nobody is wishes to go to the field, particularly a young generation. They are not adopting the agriculture as their career. Even the dairy sector, they are always going for a white collar job. That way, we have to think about this. When farmers are not producing any grain, how will we can feed to our 150 or 160 crores of mouths?
Yes, sir, you're right. There is one more question from Patem Maithiri. I am a master graduate and experienced in digital soil data. What are the research and job opportunities right now in India in the area of GIS and remote sensing in agriculture sector, especially in soil data management?
Good degree and good experience about this, but you want where you can be placed. You can be placed in ISRO, universities, research institutes, and you might have faced the competition from the geography persons, because they are more advanced in the geographical information system, but you are having a skill on working on the soil data. And once this soil data and the GIS map is developed, then you can have a good opportunity in the companies, universities, for reducing the inputs. And meantime, you can have your private business also, making the GIS maps. You can sell it to the other agencies. This is our expert maps, and even you can predict the soil test values based on that map. If you are having a good map, or a low grid mapping is being done, or high resolution images are used.
Thank you, sir. Our next query is asked by Avinash Babseet. He's asking, as India is having cheap labor due to highest population, so applying AI technologies by majority of small margin and marginal farmers is not cost efficient for them. So what solution we can make so that everyone gets the benefit of the using modern AI?
See, it is a controversial issue, and even a social aspect also. Because once a farmer goes for in search of labor, he is not getting labor. This is one situation. And the marginal small farmer, they are earning only their livelihood from working on a field. Simply they are not saving their wages. Rest everything is gone waste. The production, he can go for subsistence farming, and the earning is only the wages. And more of the now the situation is like that when the climate is changing frequently, the timely harvesting of the produce, that is more important. When labor is less, machine can done the work done very easily and faster rate, and very less spoilage of the harvest. Because early days, most of the produce they get spoiled due to negligence or delayed harvesting. This way, machines are useful, but small machines are required. Normally, big machines are available with big horsepower tractors. They are required for drawing these machines. But if you see the condition of our country, only 2 acres of land to 3 acres of land, it is the average land holding. We require smaller machines. These machines will be developed by the agriculture engineers based on the situations and the requirements. Then only we can have good.
So, sir, our next question is asked by Bibi that in Eastern India, agricultural land holdings are predominantly small and highly fragmented among many farmers. How can we apply the AI technology in the field as land of the farmer is scattered?
This land feeling was there, but still the good question, scattered farming system. Uh, I can say no. This technology is not useful for them. Just because he cannot buy several sensors for different locations. It is better to hire it. One day at one place, second day another place. But if it is a consolidated one, the field, then it is very useful. Otherwise, it is very difficult. Or he can make a collaboration with other farmers, neighboring farmers, where they are having a consolidated land. If the crop is same, he can go for spraying purpose through drones. Otherwise, it may not. Because spraying drift is there through drones. When it hovers at a place, the drift of pesticide is there, it may go on the another field. This way, this technology is good for bigger size areas. Smaller size, it is not useful. Because most of if the land holding is 10 acres or 10 hectares, it will be better. But in our system, in the country, one farmer is growing maize, another is growing paddy, and another is growing different crop. How can he go for a concerted approach for spraying or any agriculture operation, even for irrigation also, when it is not done by tube well? So one
Okay,
thing is,
sir. Yes, sir.
one thing is consolidation of land or make a cooperative with among the neighboring farmers with same crop. Then only this technology can be useful. Or a self-help group, they can hire it and divide the expenditure on the hiring charges.
Okay, sir. Our next question is asked by Prakhar Singh. He asked that he wants to become an entrepreneur and he's having a strong interest in technology. So, what skills should he learn that can be helpful in present time, also in future?
Can you repeat the question?
That he wants to become an entrepreneur.
Hmm.
So, what skills he should develop and learn so that it can be beneficial in future or as well as in present?
Uh, Being an entrepreneur, you should have one vision about the market first. Which type of technology will be useful in near future? Then your skills, natural skills about the machines and how to operate it, how to solve uh, how to rectify the problem developed in the machine. Every time you cannot hire a engineer for repairing it. So what you call it, jugaad technology, this type of multitasking person, your multitasking skills, that is required. Because if they are hiring another person, it may not be economical. Some smaller mistakes that can be rectified themselves only. And one thing good contacts with area persons, then finances, no problem. Government can provide loans, and one place which may be common, or a place which is centrally located or near the farmers, so that the farmers can easily take away the machine on a hiring basis, or he can depute one person for operating that machine. The best example you can see that the combined harvesters. These are Most of the Punjab farmers are having combined harvesters. They are going towards Maharashtra for harvesting the crops, wheat and paddy both. And once they harvest in Maharashtra, they come to MP or Gujarat or Rajasthan, then come to Punjab. In the last stage, they harvest the crop in the Punjab of the wheat, because it matures late in the Punjab. This is the best use of combine. They are using combine roughly up to 3 to 4 months in a year. Then they can earn the profit and less maintenance.
Sir, should we take more questions? Are you comfortable?
Yeah, give me 5 minutes break.
Okay, sir. I request participants to share more queries if you are having.
Okay, dear participants, till Dr. Saxena join us back after a quick break, you also can have some water and also a 2-minute quick break. So we will continue with the Q&A session. Till that time, if participants have any queries, you can send your queries in the chat section to the host and the co-host. We will be answering all of your queries, and there are so many queries which are already been addressed, and they are similar to the previously addressed queries. So if you have any more queries, please send your queries. All right, so here is a question from Mr. Abhishek Dhanawade, third year BSc Agriculture from College of Agriculture, Vijayapura, Karnataka. As agriculture students, what skills should we develop to work in AI applications in animal husbandry? So I think it was already covered during the lecture. So as a student, as a BSc graduate, you also can work on such aspects like, first of all, if you are going for the automation, there are lot many things you can incorporate in the animal husbandry or in the dairy farming, starting from feeding to the milching. Okay, so in the feeding, if you have the sensors by making hay and silage, you can monitor the adequate temperature, humidity to make proper nutritious feed for the animals. So you can take the help of AI sensors. And next, if you go for the feeding, we have the robotics, some implements or some bigger farm machineries or the dairy farm machineries, which can be used to automate your work and to minimize the involvement of manual labor. After that, if you talk about different disease diagnosis and other activities, uh, it was also discussed by Dr. Saxena that there are lot many tools and applications available nowadays which are addressing such disease diagnosis and other activities. And if you go to the milching, then there are automatic machineries which are being used for mulching purpose, and also to maintain and have the observation on the quality of your milk. So such type of implements and technologies can be used in the different aspects of the dairy, and as a graduates how you can contribute and learn such type of things. So for your kind information, dear participants, there are lot many programs by the Government of India, Ministry of Agriculture and Farmers Welfare are going on. One day seminar or one day conferences on use of artificial intelligence and different activities under the umbrella of Ministry of Agriculture and Farmers Welfare. You can register there and you can learn these new technologies. Then how you can implement. So first of all, once you learn such type of technologies, then you can continue to disseminate this knowledge to your uh, members, like your own family members, and next the villagers or the farmers you have in your village. Okay, so you can start implementing AI technologies in different practices, and you can learn from such platforms as like Agri SAARTHI, and you can implement your knowledge. So as of now, in studies, you have that ChatGPT and this different Gemini and Perplexity. And Dr. Saxena strictly asked this thing, please do not use these tools for creating your thesis and research papers. Okay. You need to sit with your books. You need to sit with the different reference books for making the thesis and the research papers and the material available on different platforms. Okay. You can use ChatGPT or some artificial intelligence tool to make your work easier, but don't depend on AI completely to work for you, like any study material or something like that. Okay, so now I think Dr. Saxena is back with us. He will continue uh, answering
एक
your
चीज
queries.
एक
Yes,
चीज थी
please.
अजय, अभी किसी का चैट बॉक्स पढ़ रहा था मैं, तो वो कह रहा है कि हिंदी में तो बता दो हमको कुछ।
जी डॉक्टर साहब, थोड़ा सा एनलाइटन कर दीजिए हिंदी में भी।
भाई हिंदी में सिंपल है, देखो एआई चीज ऐसी है कि जब हम, हमारा काम, हमें एग्रीकल्चर वाले, तो हमें जरूरत नहीं है कि सारी कंप्यूटर नॉलेज होनी चाहिए। आपको अपने फील्ड में महारत हासिल है वो रखिए, कंप्यूटर वालों से कंप्यूटर वाला काम कराइए, ना कि अपनी नॉलेज उनको देने की जरूरत नहीं है, ना बताने की जरूरत है। कि अगर एक बार आपने बता दी तो आपके हाथ से नॉलेज भी गई, सब कुछ गया। तो सिंपल था कि आपका आईपीआर आपके पास है, वो अपना जितना रिक्वायर्ड है उतना ही बताइए। कि ज्यादा बताओगे तो वो आपसे ज्यादा स्मार्ट आदमी वो लोग हैं। कि कंप्यूटर वाले हमेशा थोड़ा सा लेते हैं, बड़ा करके दिखा देते हैं, और हम उसको प्रोजेक्ट नहीं कर पाते। तो ये मेरी सिंसियर एडवाइस है आप लोगों को। दूसरा क्या है कि एआई, जैसे भी अजय बोल रहे थे कि चैट जीपीटी है या परप्लेक्सिटी है, जितने एआई टूल्स हैं, उसको कम से कम यूज करिए फॉर क्रिएशन ऑफ डॉक्यूमेंट। सिंपल, आप पहले अपना खुद लिखिए, उसको आप लैंग्वेज सुधार सकते हैं उसके थ्रू। क्योंकि अगर आपने उनसे जनरेट करना शुरू कर दिया सारा, तो आपकी थिंकिंग पावर, राइटिंग पावर खत्म हो जाएगी बिल्कुल। तो आप दो सेंटेंस नहीं लिख सकते कंटिन्यूस किसी भी टॉपिक पे। तो आजकल जैसे कहते हैं ना, ऐसे लिखा जाता था पहले, अब नहीं लिख पा रहे बच्चे। इवन ईमेल लिखने को भी चैट जीपीटी में जाता है कि ईमेल लिख दो हमारी, व्हाट्सएप का मैसेज लिख दो, वो चैट जीपीटी लिख देती है। वो तो क्या, अपना डेटाबेस बढ़ा रही है। जितना डेटाबेस बढ़ेगा उनका उनको फायदा है। और अभी तो फ्री किया है उन्होंने हम लोगों की नेचुरल इंस्टिंक्ट को खत्म करने के लिए। वर्ल्ड ओवर चैट जीपीटी पेड है, सिर्फ इंडिया में है जो 1 साल तक फ्री दी गई है। कि सारी क्रिएटिविटी हमारी खत्म करते हैं, फिर वो हमसे पैसा वसूलेंगे हर चीज का। तो ये चीज कहना चाह रहा हूँ कि अपनी नेचुरल क्रिएटिविटी ना छोड़ के बाकी सब काम कर लो आप उससे। हाँ, आप कोई क्वेश्चन हो तो पूछ लीजिए मेरे से। अब मैं हिंदी में जवाब दूंगा यार, अब नहीं दूंगा।
Thank you, sir. So, sir, the question is asked by Birendra. He's asking that could AI-driven hyper-optimization unintentionally reduce biodiversity or increase systematic vulnerability in agroecosystems?
नहीं भाई, एग्रो इकोसिस्टम, वी हैव ऑलरेडी लूज लॉस्ट आवर बायोडाइवर्सिटी। When you visualize your situation pre and post Green Revolution, pre-Green Revolution era, we are growing coarse grains, everything on a diverse scale. But after the Green Revolution, we are confined to three grasses. I should call it like paddy, wheat, and maize. These are the three staple crops we are growing up post Green Revolution. We have lost biodiversity in genetic pool of different paddy basmati varieties, wheat varieties. Now we are using the short statured wheat, less scented basmati rice that way. And even after Green Revolution, use of pesticide and fertilizer, we have lost biodiversity in the soil in form of less microbes, less pollinators, natural pollinators. That way we have lost everything. But with the help of AI, it is not going so, because we are growing a crop based on our past experiences. And that machine is giving us the direction unbiasedly that way. It is my perception. Maybe I may be wrong, but it in the future will tell ki in what capacity we have lost or we have gained.
Okay, sir. So, there is a person, Patel Hit Kumar. He's recently visited BISAG and to learn about their impressive remote sensing and geoinformatics work. He's curious that what is your point of view that satellite-based data being integrated with on-ground IoT sensor data create a digital twin of a farmer. What are the biggest challenges in merging macro-level satellite imagery with micro-level ground sensors for productive and real-time irrigation or pest control?
It is very good technology, but needs some refinement, because once the image is coming from the satellite, the person who is interpreting that image with ground truth for making the perfect decision, and later on that image is required for machine learning. The best option is the expert of the agriculture, expert of the GIS mapping. Once the mapping is perfect, then everything goes very well. The base, if base is not good, then everything go in a vain. In that case, the training of the machine, that is more important. Once, and the good quality image, ISRO is giving very good images. But how to the person who is interpreting that image and his perception, that is more important. Ultimately, human intelligence is given to the machine. We are passing our intelligence to the machines simply by 1010. That is binary. Because computer recognizes only 10. Whatever you are writing on a computer, the computer does not understand that.
Okay, so one question is asked by Dipesh Joshi that how our government is helping us. Is there any program related to AI and all these?
Government is every day they are promoting this AI. Several platforms, several schemes are available. अजय, एक आप इस पर करवा दो कहीं पे यार, जितनी स्कीम्स है ना एआई से रिलेटेड।
जी डॉक्टर साहब।
जैसे आजकल दिल्ली में कॉन्फ्रेंस चली रही है ना, कॉन्क्लेव चल रहा है पूरा एआई के ऊपर,
जी जी
जिसमें कह रहा हूँ 3 लाख रजिस्टर हुए हैं उसमें एआई पर्सनल्स वर्ल्ड ओवर। तो कभी फ्रांस वाले बैठे हैं, कभी मोदी साहब जाते हैं ना, कभी वहां कभी यहाँ, तो इंडिया में चल रही है इस टाइम
अभी डॉक्टर
करंट।
साहब इसके लिए मैं थोड़ा सा इंटरप्ट करना चाहूंगा, आपको बच्चे बार बार पूछ रहे हैं। तो डियर पार्टिसिपेंट, सॉरी फॉर द इंटरप्शन डॉक्टर साहब। देयर इज ए रिसेंटली एप्लीकेशन लॉन्च्ड बाय गवर्नमेंट ऑफ इंडिया, दैट इज भारत विस्तार, जिसके अंदर आपका जो है फुली एआई enabled आपका एप्लीकेशन है, एंड it will be active for 24/7. Okay, it was recently launched, and there is a facility for the calling because our farmers are not aware about using AI and these recent advancements, so they can easily call on a toll-free number. Actually, earlier we had a toll-free number, that is 1-800-180-1551. That is common for everyone, but now a dedicated helpline is released. I have shared the document with Dr. Saxena. I think he will be also enlightening on this. So there is a dedicated number. It is 155-672. If any farmer or any one of you will connect this line, it will always be available for you. There will be AI support, and what it will provide you, it will provide you the advisory regarding your weather and your environmental conditions and the upcoming different ICR. There are different IMD, Indian Meteorological Department advisories regarding the weather and different crop decision support system and crop management techniques. Everything will be there on this particular application. And if you face any type of difficulty to browse that application, you can simply call and take the help. The AI only will answer the queries, and if there will be anything that is not out of reach of the AI, then you will be connected with some of the experts. So this is the facility which is being provided by the government of India. And as Dr. Saxena well said, there is also a conference is going on, and in the coming days, like 20th and 21st, there is another conference which is also based on this artificial intelligence and utilization for our farmers. So such type of initiatives are being taken by the Ministry of Agriculture and Farmers Welfare. You should also be aware, and you can browse to the website that and the press release by the PIB. So thank you so much, Doctor. We can please continue.
Okay, sir. So one question is asked by Aditya Kumar that as we build the futuristic decision support systems, how is the NDRI addressing the challenge of model explainability? Specifically, how can we ensure that AI is logic is transparent enough for a farmer to trust a high stake recommendation, like an expensive medical intervention or a major change in breeding strategy rather than it is just being a black box output?
You continue.
Yes, sir. So the question is how AI is addressing the challenge of modern explainability.
Uh,
Okay,
for
can
animal
you?
sector,
Yes, please let me decide this question, Doctor.
Yes, sir,
Uh,
please, sir.
Okay, so this is Aditya Kumar, sir. Good evening, Dr. Anurag Saxena. Thank you for sharing your expertise. My name is Aditya Kumar, and currently I'm pursuing BTech in Food Technology from Central Agriculture University, Imphal. My question is, as we build these futuristic decision support systems, how is NDRI addressing the challenge of model explainability? Specifically, how can we ensure that the AI logic is transparent enough for a farmer to trust a high stakes recommendation like an expensive medical intervention or a major change in breeding strategy rather than it just being a black box output? This is the question, Dr.
yeah, because we have to believe the technology, because we are not believing our doctors nowadays, but we are very well believing our WhatsApp university messages and Facebook messages and any type of bullshit we are believing, but not our doctors. Simply the machine, that machine is predicting, it is based on our previous data. That way we have to believe it, because nobody wants to cheat anyone and machine never. Because training a machine, it is a combination or a effort of lot of persons. It is not an individual one. Several persons are joined hand for making the machine trained or different type of outputs and different data, different situations. That is fed in the computer for training a model. Once a trained model is predicting, that is perfect one. Everybody has to believe it, undoubtedly, because we have to believe someone. Otherwise, the world will not will go in a right direction. Always doubting means something fishy in our perception also. That is my message. Whatever machine is giving, it is based on the hard work of different individuals, and they are not cheating to anybody. And that way, the whatever that is predicting, it is well and good. Just like robotic surgery, the best example. Human surgery is being done with the robots, with the help of robots. The doctor is sitting 1,000 miles away from the patient. Simply by the mouse click, robot is doing the surgery of a human, and in a better way than the doctors. Because human hands, वो कांप जाते हैं कभी कभी, लेकिन रोबोटिक आर्म बिल्कुल परफेक्ट इंसिजन करती है, वहीं ऑपरेट करके आ जाती है, ये चीज।
Thank you, sir. Sir, I want to ask for your permission to ask a few more questions.
कितने क्वेश्चन है यार, और खत्म ही नहीं हो रहे। ठीक है, चलो।
Sir, this is a question from Mayuri Samal. Good evening, sir. I am Mayuri from Maharashtra, a BSc Agriculture graduate. Sir, how can AI-based decision support system improve profitability and risk management for small and medium dairy entrepreneurs?
See, for improving the productivity and profitability, it is a comparative term or relative term. Once you are able to reduce your expenses or input cost, then you can run a profitable business. Otherwise, you will be a loser, because input or inventory cost, that has to be reduced, or the whatever resources which are available with you, use it judiciously. Simply, if you require one injection, you are purchasing 2 or 3 injections, that is not useful. Simple single dose is sufficient for controlling a disease. That will be good enough. And simply खर्चे कम करोगे तो कमाई ज्यादा होगी, नहीं तो नुकसान होने का पूरा चांस है। यही एआई कहती है कि आप बिल्कुल जुडिशियस इनपुट को यूज करिए, तो आपका खर्चा बचेगा, इससे आपको फायदा होगा।
Thank you, sir. This is my last question, asked by Gauri Shankar Tripathi from Deen Dayal Upadhyay, Gorakhpur University, BSc Honours Agriculture. His question is how the expenditure and profit manage while using AI-based machine, because these machines are expensive, so this may lead to the market price uplift. So how to manage a new culture of AI in farming in respect to expenses and profits?
Uh, I was telling you since evening that there is no need to purchase each and every machine at your farm. Go and hire it. Always hiring business is easier and profitable one. Simply, if you are investing 1 lakh for purchasing one machine, and you can hire in the same price several machines. And if you are purchasing a machine that will not be used for whole year, means simply the best example I can put to you is just like having a car in your house and hiring a taxi. If you are purchasing a car, you are investing 10 lakhs of rupees plus maintenance, plus petrol and everything you are spending on this. While and even more mental fatigue is parking of that vehicle, driving on a road like that. When you hire a taxi, you go for a 1 day, 2 day, 3 day, and every botheration is with the driver or taxi owner. Simply you are saving 90,000 rupees or 9 lakh rupees or like that, and that can be used in other enterprises that way. And your car is not daily usable. Simply nowadays parking is very costly. For charge on an hour basis, 100 to 200 rupees per hour in depending on the cities. So this type of expenditure we are not counting. Similar way, when you are purchasing a machine or AI machine, that will do a work for a single operation or two operation maximum. But you have to use multiple operation, you can hire it. And no need of maintenance, no need of investment on the maintenance cost. That way you can promote this type of technology on a self-help group or cooperative basis or a village basis or a larger group or larger consolidated land holdings.
Thank you,
Thank you,
sir.
sir. Thank you all
The-
the participants for your active participation and thoughtful questions. And special thanks once again to Mr. Saxena for patiently addressing them. And with this, we come to the end of the interaction, and I now invite Ms. Kanishka to deliver the vote of thanks. Kanishka, please.
Thank you, Simran. On the behalf of Agri SAARTHI team, I would like to express our heartfelt gratitude to Dr. Anurag Saxena for delivering such an enlightening and impactful session on AI and animal smart DSS in agriculture and futuristic animal husbandry. So, your valuable insight on use of information and communication technologies in agriculture, remote sensing, application of fraud in agriculture, animal behavior sensor, etc., have greatly enriched our understanding. I would also like to thank all the participants for your enthusiastic presence, engagement, and meaningful questions, which made today's session truly interactive and successful. Finally, my gratitude to the entire Agri SAARTHI team for their continuous effort in organizing this 30-day National Agricultural Training Program and for providing such a valuable learning platform. Thank you all once again for joining us today. We look forward to your participation in upcoming sessions for Agri SAARTHI KRANTI 2026. Have a nice day ahead. Jai Hind.
Thank you. Good night.